Compound interest and depreciation. Part 1. Compound interest rule. When money is invested with an institution such as a bank, then the institution pays interest for having the use of the money. Interest is usually expressed as a rate per annum, per year. The symbol we will use for interest rate is I, which is the interest rate expressed as a decimal or a fraction. For example, for an interest rate of 4%, I is equal to 4 over 100, which is equal to 0.04. Suppose €100 is invested for 1 year at an interest rate of 4% per annum, per year. Then at the end of 1 year, the interest gained is 4% of €100, i.e. €100 times 0.04, which is €4. The final value of the investment at the end of 1 year is €100 plus €4, which is €104. In general, suppose P, called the principal, is invested for a year at a rate of interest I per annum per year. Then the final value F at the end of 1 year is given by F equals P plus P times I, which is F equals P times 1 plus I. This gives us the rule for compound interest calculations. The phrase compound interest refers to the fact that interest gained is immediately treated as principal. The rate of interest assumes that the interest is added at the end of the period, in this case 1 year. So P stands for principal and F stands for final value. Compound interest rule. To find the future value F at the end of 1 year, when the rate of interest is I per annum per year, multiply the principal P at the beginning of the year by 1 plus I. This rule may be used for year after year calculations, especially when the rate of interest varies from year to year, some money is added to the investment or removed from the investment at the end of a year before the investment continues. In some questions, we may have to work backwards to find the principal at the beginning of the year, or we may be asked to calculate the rate of interest for a given year. In such questions, we lay out the calculation on a year-to-year basis as seen in example 1. A sum of money was invested for 1 year at 6% per annum per year, compound interest. Part 1. After 1 year, the investment was worth €3,710. What was the sum of money that was originally invested? So we're going to let P be the principal at the beginning of the first year. So for year 1, I, the interest rate, is 0.06. We got that from here. 6%, 0.06. So at the beginning, we just have the principal amount, which we do not know. At the end, we have the principal amount multiplied by 1.06. This is 1 plus 0.06, which is 1.06. This gives us 1.06p euro. We were given that 1.06p is equal to €3,710. That was the investment after 1 year. So now we just solve for p. So P is equal to 3,710 divided by 1.06, which is €3,500. Thus, the original sum invested was €3,500. This was the principal amount. Part 2. At the end of the first year, €500 was withdrawn. The rest was invested for a further year and grew to €3,370.50 at the end of this year. What was the rate of interest for this year? And give your answer as a percentage. We're going to let I be the rate of interest for the second year. So for year 2, at the beginning, we have €3,710, and we're going to subtract the €500 which was withdrawn. That leaves us with €3,210. So at the end of year 2, we have €3,210, and we're going to multiply that by 1 plus I. So what was given was €3,210 times 1 plus I is equal to €3,370.50. So that was given in the question. Now we just solve for I. So we're going to divide by €3,210, and that gives us 1.05. And then we're going to subtract the 1, so we're left with 0.05. So I is 0.05, thus the rate of interest in the second year is 5%. Part 2, Compound Interest Formula. So here in the pink box we have our compound interest formula. So the future value F, to which the principal P grows at a rate of I per annum, compound interest after T years, is F equals P times 1 plus I to the power of T. This formula can only be used if the rate of compound interest stays the same throughout the period, so the I stays the same, and no sums of money are added or removed during the period in question. The formula can be used to calculate any one of the quantities F, P, I and T given the values of the other three. And it's found on page 30 of your formula tables. So this is our compound interest formula, where F represents the final value, P represents the principal. What sum of money invested now at 4% per annum per year compound interest will amount to €1,052.87 after 4 years? Give your answer correct to the nearest euro. This time F is the sum given and we want to find P. We want to find the principal amount. I is 0.04 and T is 4. So F is equal to €1,052.87. I is 0.04, T is 4, and P we do not know. We're trying to find out the principal amount. So we use our compound interest formula. We swap the F for 1052.87. That's equal to P times 1 plus I, which is 0.04. So 1 plus 0.04 is 1.04. And then we swap the T for 4 years. Next we solve for P. So 1.04 to the power of 4 is 1.16985856, and then we stick on the P, and then we're going to divide the left hand side by that number. So we have 1052.87 divided by 1.16985856, and that gives us P equal to 899.9976, which rounds off to 900, correct to the nearest euro. Thus the initial sum of money was €900. Part 3, depreciation. This is known as reducing balance method. Suppose a company buys a new car for one of its sales representatives at a cost of €24,000. As the car gets older, the value decreases. This is called depreciation. In its company accounts, the company needs to keep track of the change of the value of the car for 2 reasons. Reason 1, the depreciation, or loss in value, is a legitimate business expense and can be set against profits. Reason 2, the value of the car at the end of each period, usually a year, called its later value or net book value, NBV, is a company asset and has to be recorded as such. Data shows that for the make and model of car bought, the car loses 25% of its value over the period of each year. Suppose the company keeps the car for 3 years, and we want to determine the depreciation and net book value each year over this period. The following method of calculation is called the reducing balance method. Year 1, the original value of the car was €24,000. The depreciation is 25% of the original value. 25% of 24,000 is 6,000. And subtracting, we're left with the NBV, which is the net book value, which is €18,000. So at the start of year 2, the value of the car is now €18,000. Again, we get 25% of this amount. We get 25% of €18,000. That's 4,500. And we subtract, and we're left with the NBV, which is 13,500. At the start of year 3, the value of the car is now 13,500. We get 25% of 13,500, and that is 3,375, and we subtract this to be left with the NBV, which is 10,125. An alternative, simpler method of calculating depreciation is called a straight line method, under which the asset loses a fixed amount each year. However, the reducing balance method is a more realistic approach to depreciation and is the only method on our course. It might also be necessary to work backwards in depreciation questions. Example 3. A manufacturing company buys a machine, which they know will depreciate at the rate of 15% per year. In the second year, the depreciation of the machine is given as €5,737.50 in the company accounts. Find the original cost of the machine. So, in year 2, the depreciation in year 2 was €5,737.50. So that's how much the machine went down by. And since it says in the question that it depreciated at a rate of 15%, then this must be 15% of the value at the start of year 2. So if this is 15%, we want to find 1%. So we divide by 15 and we're left with 382.5. So 1% of the value at the start of year 2 is 382.5. To multiply by 100 will give us 100%, and that gives us 38,250. So the value at the start of year 2, 100%, is 38,250 euro. So now we need to work back to year 1. So in year 1, the later value at the end of year 1 was 38,250 euro. So this was 85% of the original cost, because 100% minus the 15%, which is the depreciation rate, is 85%. So this amount must be 85% of the original amount. So again, we're going to find 1%. So we're going to divide by 85. That gives us 450 euro. So that's 1%. And now we find 100%. We multiply by 100 to get 45,000. So the original cost of the machine, 100%, was 45,000 euro. There's a formula for depreciation, just as there is a formula for compound interest. Suppose an asset of value P depreciates at the rate of I per annum per year. Let F be the later or future value after T years. Then F is equal to P times 1 minus I to the power T. So here we have our depreciation formula. Example 4. A company buys a machine on the understanding that it will be able to dispose of it in 8 years' time for 10% of its original cost. Find the annual rate of depreciation as a percentage correct to 2 decimal places. So we let P be the original cost, then F is going to be 10% of P, which is going to be 0.1p, because 10% is the thing is 0.1. Because remember, it told us in the question that after 8 years, the machine is 10% of its original cost. So its final value will be 10% or 0.1 times P, which is the original cost. We're going to let I be the annual rate of depreciation. Then we substitute into our formula. We swap F, which is the final cost, or the future value, for 0.1p. P stays as P because we don't know what that is. That's what we're trying to figure out. We're trying to find the principal amount. We're trying to find the original amount. The I stays as I because that's what we're trying to work out. We're trying to find the annual rate of depreciation. And then the T becomes 8 because it was 8 years. It told us in the question 8 years. So now we have an equation in terms of I and P. We can cancel out the P's because we've one on either side. And now we just solve for I. So we have 0.1 equals 1 minus I to the power of 8. The 8 comes over the equal sign and becomes to the power of an eighth, or the 8th root of 0.1. So 0.1 to the power of 1/8 is the same thing as the 8th root of 0.1. And that gives us 0.74989, which we bring over the equal sign and becomes a minus. We bring the minus I over the equal sign on the other side, it becomes a plus. So we have I equals 1 minus 0.74989, which gives us 0.25011. Thus, the annual rate of depreciation is 25.01%. And here you will find the depreciation formula on page 30 of the formula tables, where F represents the later value and P represents the initial value.